Hello everyone. Today we'll be diving into like a real art of assembly. Literally, we are going to demonstrate and construct an x86 program which would be printing a hollow right angle triangle. Now, most of the high-level languages give you simple print function like C gives printf. In assembly, we have to talk directly to the kernel, and the program that I am going to introduce right here would be making use of Linux system calls through interrupt number x80 or ATH to display characters and C library functions. Okay, to take user input. Let's look at the blueprint. Right, so let me write .asm. So here we'll declare because we want an hello one. So that's why we'll require to display the like to add the characters. So let me add section dot data, which would be containing star. Okay, which will define as like this. Okay, then we will have space because we will requiring an hollow space in between the space because we want to print an hollow triangle, correct? So space would be required between two stars. Fine. Then we will require a new line because after one line is printed, it should go to next line. Then as we are going to make use of like a scanf to ask how many number of like what is the size of the triangle. I mean to say size in the sense number of rows to be covered. So msg db percent d. Fine. Now as we are going to have message percent d, that's why I will declare one variable n, which would be giving you size. So I will talk about it like res d. Then section dot text global main. Now, if you see this particular code, I have written three sections. So though I haven't written anything with respect to text, but section dot data, this is initialized constant where we defined our building blocks, the star, space, and the new line. Correct. And as well, like I have added that percent message percent because we want to display, we want to read the number. That's why the scanf is expecting to have percent. So section.bss, this is initialized variable where I reserved 4 bytes for n to store how many rows the user is expecting. Now we have to write main. Okay, this is where the magic starts. We use scanf to get the value of n. Okay, now let us see like how exactly the code would be. So then I will describe it. So push n. Okay, push n. Then we have to push the message because we want scanf to be written. Scanf percent d ampersand n. That's the reason we call scanf add est comma 8. So this will read n, correct? Then like if you see the code that we're going to write, like as we want to print the triangle. Now to print that 2D shaped triangle, we need two loops, one for the rows and one for the columns. And this main actually is the mechanism where the magic starts. So as I used scanf to get value of n, then we are pushing address of n, then format string percent %d onto the stack before calling scanf. Correct. And in 32-bit assembly, the stack is our primary way to pass arguments to the functions. Correct. Now, what we'll do is we'll use two loops, outer loop and inner loops. One would be for rows, other one would be for columns. So outer loop would be working with rows, and inner loop would be working with columns. So what I'm going to do is I'm going to make use of EDI register for the outer. So initially, like as we are going to print first line, so let me write move EDI equal to 1. Sorry, move EDI comma 1. Now let me write outer loop. here. Now we know exactly that we want to print n rows, correct? So we have to compare d word of n. This would be compared with EDI, correct? EDI d word of n. Now, if this is greater, that means we are done. We should exit. My exit. If it is not greater, then we have to work with columns. So I'm using move EBX as my counter for the columns. So I'm saying 1. So I will write here outer loop, and then I will write inner. So let me write this way. Yeah. Now, like if suppose my inner loop counter and my outer counter, like the number of rows, if that matches, that means what? We have to go to next line. So that's why we will write here CMP EBX, EDI. Then we should go to next line, and that's why we have to print new line character. So print new line. Fine. Now let us understand here. Now, if you see what I used here, EDI register as our row counter I, okay, which is starting with 1. That's why we said move EDI, 1. Then we are comparing EDI with, so this is simply to say that if our current row exceeds the user's input N, then we are done this loop, correct? Now, inside each row, we use EBX as our column counter. And this loop runs until J is greater than the current row number. That is EBX greater than EDI in our case. So row number is I, for example. Now, like we have to print hollow logic too in between when we write the code. So now there are 3 conditions involved. So this is the most critical part of the code which I am going to write now. If we print a star every time, we would get a solid triangle, correct? To make it hollow, we only need or print a star if we are on the borders. So in this program, we check 3 conditions, correct? Like the 3 conditions would be checked to print a star. So first is like if we are at the first column, that means compare EBX, 1, then we print star. Now, if we are on a diagonal one, where column equals row, okay, because we want an hollow one. So if as print star. And lastly, if we are on the last row, that means EDI and divide of n matches, then we have to print star again. So if none of these is true, we fail through the space logic, correct? So this is how we create the empty center of the triangle. So let us write that code to get it done. So I will include for our reference conditions. Conditions are conditions for border. So let me write first. So print star if I'm saying J, correct? J means what? EBX. If EBX equal to 1 or EBX equal to EDI or EDI equal to N. Correct? This is the logic for us. So let us compare first. So CMP EBX, 1. So if it is 1, so we should print star. So let me write here print star. So and we are going to make use of a write system call. Now second condition would be like if this fails, suppose if it is not first row, that means it would be like the border, correct? Border lines. So compare EBX, EDI. Again, this should be jump if equal. Jump if equal, then print star. And third case, like when both of them, like this is second, then last one is if it is the last row, then EDI, the word of n, correct? Then again, we have to print this, correct? So these are the 3 conditions that we are having. Fine. Now, if either of them is not there, that means what? If either of these three conditions doesn't exist, that means what? There is going to be an hello logic. So we'll print here. If none of the condition holds, then else print space. So let us write. So push A, because I'm going to make use of registers, EBX would be modified. So that's why I'm using this. So move write system call is 4. EBX where to print is 1. What is to be printed? Space. So ECX comma space, and then move EBX comma EBX we already gave. EDX is length, correct? So that's valid. And then int 0x80, correct? And then pop in. Now what it will do? We have used a system call to print this. So if once it is done, then we have to move to printing the next column. Like once one space is done, then we have to repeat this, correct? So I am saying next column. Now let me write like the code for print star. Fine. Now here, what is to be done again? Similar kind of code. So I will take this. Instead of space now, it would be star. So I will just replace space by star. Correct. So this would be for printing as one space, and this would be printing one star character. Now, like once the star character is printed, we have to go to next column. Next column. What is to be done? We have to increment that internal counter. Correct. And jump inner. So inner loop, I assume I have taken, inner loop. Fine. Now, if inner loop is done, what is to be done? Like inner loop, I mean to say the space is printed, the boundary columns are printed, like with star, space is added. Then what we have to do is we have to move to printing new line. Print new line. Correct? So I assume we have taken somewhere, print new line. Correct? So print new line will contain now again the similar kind of system call. So here just we'll write here instead of CX, it should be new line logic. Fine. Now, once new line is done, we have to increment EDI, and we have to continue with outer loop. Outer, correct. And I assume this would cover the whole thing. Now, if you see what we have done here, is using the system call, correct, below. Like as I stated earlier, these three conditions. So once the three conditions are satisfied, then there is a task for us to print either a space, a new line, or a star. And that's why we are using, say, the system call write, correct, with system call number 4. So which is also known as syswrite. Okay, so EX comma 4 system call number, EBX comma 1 means it should write on the terminal. That's what standard output. What is to be written? So ECX comma, like either it would be say space, new line, or star, and EDX comma 1, which tells how many bytes. So one character we want to print. And INT80, the interrupt that pauses the program and handles the control to the OS and hands over the control to the OS to perform the task. Notice that we are using push a pop a in either of the case, because this to save all registers before the system call and restore them after, and which will prevent uh, accidentally overwriting our counters, like for example EDI or EBX. Okay. Now let us go back and add only that exit system, because we have to terminate. So we said somewhere my exit, correct, here. So once it is done, when column matches, then jump in. So we have to write my exit column, and exit system call I'm using move ex comma 1, exit system call number is 1. Then exit 0 we write, that's why we will write XOR EBX comma EBX, and then int 0x80, and then if required, like no need to write now return, because we directly are removing it. So instead of this, you could have written RET. Fine. So we are done with this code. So let us try assembling it. Asm dash APLF 32 my triangle. Fine. Dot inside dash G dash M2R. Okay. So we have to add external scanf here after main. Let's go back. We are done. So GCC dash M32 my triangle dot O dash G dash M2R. Then execute. Dash A dot out. So let us see if I give 5. Let us see what it displays. So we got this. So give 10, give 20, correct. 20. So we're going beyond, correct. So you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can go on. You will see 30 characters are printed. So this is the code that we used to display the triangle. So let us conclude. What we have seen here, like once the inner loop finishes, we print a new line, correct? Like this is the first character, then we printed second, then we printed third, then we had number of spaces depending upon the counter. The counter EDI and jump back to the start of the outer loop. So when EDI finally exits and hit exit block, so which calls the system call to shut down the program, correct? So what is happening? We are reading value from user loop starts from 1 to n, and the row loop starts from 1 to n, and column loop starts from 1 to row number of rows, correct? So check if we are on border, so first column, last row, or a diagonal, and print accordingly star, space, or even slash n, correct? We're using INTAT, and repeat this until the shape is complete. Fine. So this is how it works.